Today we're going to be looking at special cases. The X method that I showed before always works. Looking at question number 9, I can just say I'm looking for two numbers that multiplied equals 25, but when I add them it's equal to 10. I can easily think, well, this is 5 and 5. Because my first number is a 1, then I can go straight to parentheses. V plus 5 and V plus 5. This is a special case because the parentheses is the same. So I can write this as b plus 5 and p plus 5, or I can just say I get b plus 5 twice. We call this perfect square, means I get the same parentheses twice. All right. Number 10, it also works. So this X method will always work. I'm looking for two numbers that when I multiply them is 24, but when I add them is 24, but when I multiply them is 144. Remember, I multiply first and last. That's how I got 144. In this case, I'm thinking positive 12, positive 12. Because my first number is not a 1, I'm going to split my middle term. So I'm going to go 9n squared plus 12n plus 12n plus 16. Looking at the first two terms, I can divide each by 3n. 9n squared divided by 3n, I get 3n. 12n divided by 3n, I get 4. Now looking at these last two, 12n plus 16, let me divide each by 4. That gives me 3n plus 4. My parentheses that match, the repeating parentheses, is 3n plus 4. And so is the other one. So I'm just going to I get 3n plus 4 twice. We call this special cases because I get perfect square. Now, I could have done this a little bit easier. Special cases, this happens only on special cases. Let me get the square root of the first term and let me get the square root of the last term. The square root of v squared is v. The square root of 25 is 5. If I multiply these two, 5 and v, and I get half of the middle term, I have a perfect square. So this happens only on perfect squares. 5 times v has to be half of the middle term, which in this case it is. I respect this plus sign. I'm going to put it there. If I had a minus, I would put a minus instead. And I have v plus 5 squared. Looking at number 10, I could have done this the same way. The square root of 9n squared is 3n. The square root of 16 is 4. 4 times 3n is half of 24n. So I have a perfect squared. Respect the plus sign. This happens only on perfect squares. Now let's take a look at number 11 and 12. I only have two terms. There's a minus in there. I know how to work three terms. So let's do a squared plus 0n minus 16. I'm going to add a 0 as the middle term just so I can do my x thing. I'm looking for two numbers that added is equal to 0 and multiplied equals negative 16. We could be thinking positive 4, negative 4. Because my first number is a 1, I go straight to parentheses. A plus 4, a minus 4. Same thing with question number 12. I could just say 4x squared plus 0x minus 25. I'm adding a middle term just so I have three terms. I'm looking for two numbers that multiplied equals negative 100. But when I add them, it's equal to 0. So it's going to be 10 and negative 10. I can split this as 4x squared plus 10x minus 10x minus 25. From here, let me divide each by 2x. That gives me x plus 5. From here, let me divide each by negative 5. That gives me 2x plus 5. So I have 2x. Oh yeah, this is 2x plus 5. I have 2x plus 5 as the parentheses that repeats, and I have 2x minus 5 as in what I have on the outside. So notice the x term always works. However, this is a special case. It can be done different. Let me get the square root on each. Looking back at 11, square root of a is a. The square root of 16 is 4. So I can do the square root. There's a minus sign in between them. It works only if I have a minus sign in between them. Now, the a and the 4, I'm going to use those. My parentheses are going to be a plus 4 and a minus 4. One of my parentheses has a plus, the other one has a minus. If you notice, my answers are the same thing. Looking at number 12, I'm going to do the square root on each. The square root of 4x squared is 2x. The square root of 25 is 5. So I'm going to use the 2x and the 5. It's just that one of my parentheses is going to have a plus, and the other one's going to have a minus. You guys can see I'm going to get that. Once again, the x thing always works, but these are special cases, so this is how they get treated with special cases.